Of course. I was saying I'm going to give a quick presentation about the future in fire and adaptation in grassland. Um, there we go. So Max and others already kind of talked about this, like the fire regime. He said what we need climate, we need vegetation, and across most of the US, it's human activities that they start most of the fires. And again, Kira and Max kind of already hit at, we have fuel limited fires in drier and warmer ecosystems, and then we have climate limited fires in cooler and wetter ecosystems. And for the past in the Great Plains, we've had high fire activity during moist intervals when there's been a ton of grass available where higher fuel loads, so we can have lots of fires, or we have low fire activity when the fuel loads have decreased because of greater aridity. There's not enough moisture to grow that fuel to have that fire. So we've kind of seen similar maps to this already. So we've seen increased wildfire across all of the West, but here we want to focus on the Rocky Mountains, the Northern Plains, and part of our region, which is kind of encapsulated in the Southern Plains. And so we see in the Western steppe ecosystems, cheatgrass is well known for increasing the fire frequency, where in mixed grass prairies of the Great Plains, increased annual brome grass has been associated with less frequent fires. So invasive grasses don't always increase fires. You can have the opposite impact. Focusing specifically in the Great Plains, this shows that the change in fire density and like number of fires from the 80s to mid 90s, the 90s to 2000, and 2005 to 2014 across different parts of the plains. So we have the Central Plains, Flint Hills, High Plains. And so what we've seen is that the number of large wildfires have increased threefold. And the area burned has increased by 400%. The probability of large wildfires has increased by 70%. And for some of these regions, like the Northwestern glaciated plains, we've seen a shift in seasonality. Where back in the 80s to 90s, the peak happened in April, and now we're seeing that in the late summer to early fall. So besides the number of fires happening, in most, we see that the highest has happened in the red, which is the 2005 to 2014, but we also have shifts in seasonality occurring. So also we can look at the fires by land cover type in the Great Plains. This is from the 90s, 1993 to 2014. So woody vegetation in grasslands had the greatest propensity for large fires. And so woody vegetation burned disproportionately more, over 2 times its proportional land cover. So its land cover is less than 20%, around 15, but its percent burned, the total area burned is over 30, whereas crops, which occupy over 30% of the land cover in the Great Plains, they burned over 15 times less than its proportional land cover. And we know that's due to the irrigation. So that water content of crops has led to less burning in croplands than the grasslands or woody vegetation in the Great Plains. But despite these fires on grassland vegetation, we haven't seen a persistent shift in vegetation cover driven by this wildfire. So this is showing for, again, those same ecoregions you saw before. So the Central Plains, here's the cross timbers, Flint Hills, the Northwestern glaciated plains. What we're seeing is the mean perennial cover, and then the red lines are when a fire occurred. And so it's the years since fire. And for all the vegetation groups, we see rapid recovery to pre-wildfire levels. The only persistent change is that there's a decrease in the abundance of trees in the Northwestern Great Plains, and that wildfire didn't have the biggest impact on the variation in the annual forb or grass cover. That is more influenced by climate or grazing. And the variation between wet and dry years can see a 400% difference in grass cover in the Great Plains. So climate's a big driver of the change in ecosystem coverage. So looking to the future, we can look at, this is a modeled index. It's the KBDI is an index of drought, kind of similar to what Kira was talking about earlier with BPD. And so what we see is that regions that already had high fire danger in the West are going to have even longer fire seasons that span winter, spring, summer, and fall. In regions that used to have low wildfire potential, which is us in the Great Plains, are seeing a larger increase in periods with this higher KBDI, so extended drought conditions. And so because of this dryness, in the future, these regions are going to experience higher wildfire danger. So this is looking at dryness, but if we look at fires specifically, this group modeled the future fire probability. And so this picture is showing the change in annual fire probability. The percent change is comparing from the 1970 to 2000 and looking at the end of the century, 2070 to 2099. And this is based on the RCP 8.5. And so we see that the rising temperatures are the primary cause of the increase in fire probabilities. And fuel is the most important driver for the high severity fire, followed by the fire weather and topography. So we can see in the Southern Plains in Texas, there's actually a decrease in fire probability, but most of the United States had a significant increase. And for parts of the Northwest that didn't have much fire before, the fact that they're going to have fire in the future, the percent change is quite high. But we can see we're in the middle of that percent change in the Northern Great Plains. So that's for annual fire probability. We can also look at the future of very large fires. And so again, this is that same period in the past. So looking at the number of very large fire weeks, so the conditions that can lead to very large fires. And then this is mid-century, 2040 to 2070. And again, the percent change between what we've seen in the past and what we expect in the future. And the largest relative changes in fire probabilities were found across the northern tier of the US. So you can see lots of parts of Montana, the Dakotas is the darkest, the most change. And so again, this change results in the fact that in the past, we've had very small amounts of very large fires, but the conditions are changing. And so because of that, our percent change is going to be large. But then we can also see for large portions of our region, there's a lack of information. So the gray means that there is no model information for that. So we're missing some key information for large portions of the Great Plains. So what can we do about fires? So a lot of the practice is prescribed burning. So a prescribed fire is an application of a fire to achieve some objectives, whether it's restoration or maintenance of an ecosystem. And to have a successful prescribed fire, you need sufficiently warm temperatures, low relative humidity, at least some wind, but not high wind. And again, you need your fuels to be dry enough to sustain that fire. And so some research done across the Great Plains has showed that from the early 2000s to mid 2015, that the number of acceptable spring fire weather days has decreased, but we're seeing that shift to that there's more days in the late summer and early fall where this is acceptable. And this is important for grassland management because when you apply fires to either limit invasives or encourage a specific vegetation type or decrease woody encroachment, the timing of your burns changes. And so the fact that the window in the spring is decreasing is important for grassland managers. Another type of, so currently we're seeing, this figure shows there was a survey done of land managers in the Northern Great Plains. And so the figure on the left shows broken down by tribe or forest service, national parks, like Bureau of Land Management, any of those, that their desired fire return interval is much smaller than their estimated fire return interval on their land. So they want to apply more fire and they want to have it occur more frequently. But what we're seeing is that most of their lands haven't had fires in sometimes 50 plus years. And then there's the Natural Resource Conservation Service, which is a federal agency to, they're mandated to assist private landowners meet land management goals. And they were surveyed to see how often, what's the most common assistance they provide private landowners. And they mostly provide education, and they rarely conduct burns or provide equipment. So there's, even if private landowners want to apply prescribed fires on their land, there's not a lot of resources for them, even given from an agency that is supposed to be helping them. So that's prescribed fires. Another thing is grazing. So without grazing, excessive litter can build up. If there's either light grazing or no grazing, and excessive fuel loads is how we get large fires. But in the North American tallgrass prairie, one of the common invasive species is actually less flammable than the native grass. And so it increases the fuel bed density and has a higher moisture retention. So it changes the fire dynamics on that land. And so in terms of trying to burn to get rid of invasives, that doesn't work with this one. And also grazing can sometimes have the undesired effect of increasing invasives, because certain ones are palatable when they're young, but less so when they're fully grown. And so grazers avoid them. And so again, if you were looking at this purely as a fire, you have less fire on your land. But if you're trying to maintain the ecosystem, limit woody encroachment, like have fire return intervals, having this invasive is not good. And so the last practice is called pyrrhic herbivory, or patch burn grazing. And so where you apply the two together. And so what you do is grassland, you rotate between burned, grazed, and then you have a transition. And so when you burn, you have high production and availability of the forage. You transition, you have bare ground, low litter, and standing biomass. And so we have our grass accumulating. And so what you want is you want to have burning and grazing, because the cattle actually spend 75% of their grazing on the most recently burned patches. And so then it allows the grasses to grow on the recently unburned. And then you can rotate between graze, burn, transition. And this helps keep woody encroachment down. Because if you stop having that, the woodland starts encroaching in grassland, and then through time, you actually decrease your grasses and you have more woody plants. So these are some of the things grassland managers have to consider. So I will end there.